Example, probability using permutations or combinations number 1. As we work through the next few questions, we've got to remember how combinations and permutations work, but in the end, we're going to be finding a probability typically. So in horse racing, an exacta bet is one where the player tries to predict the top 2 finishers in a particular race in order. If there are 9 horses in a race, and a player decided to make an exacta bet at random, what is the probability that they win? Now, this question hopefully seems familiar because we previously used a permutation to determine something like top 2 finishers, first place and second place. And so actually we need exactly that. In order to find the number of ways that these 9 horses can possibly land in first or second place, we would use 9p2. Permutations of 9 items taken 2 at a time. The difference would be, in order to find the probability that they win, well, of those however many possibilities, there is only one winning combination. So I'm going to write this as a fraction, 1 over 9p2. Now when I pull my calculator up, I'm going to calculate one piece of this at a time. I'm pulling up class calc here on my screen. Remember, we can press stat and then NPR from your scientific calculator page to get NPR 9, 2, which is 72. So this probability will be 1 out of 72. Now, if you don't want to do this one piece at a time, in order to get a fraction answer, you would type in 1 divided by stat NPR 9, 2. And if you notice, I get a decimal, 0.013 and then 8 repeating. And if I choose the number symbol here to change this to a fraction, then I get 1 out of 72. Same answer, which it was the goal. All right, next example. Probability using permutations or combinations number 2. Palmetto Cash 5 is a game offered by the South Carolina Education Lottery. Players choose 5 numbers from the whole numbers between 1 and 38 inclusive. The player wins the jackpot of $100,000 if the randomizer selects those numbers in any order. If you buy 1 ticket for this game, what is the probability that you win the top prize by choosing all 5 winning numbers? There's a phrase in this that, again, I hope feels familiar. It's this. It says, in any order. Because we're choosing numbers in any order, this is a combination, not a permutation. And so what this comes down to is that we are selecting one choice of numbers out of a possibility of 38C5. There are 38 numbers. We are choosing 5 of them in any order, so we're using combinations. So if we pull up our calculator again, we can type in stat NCR 38, 5, and we have a number of outcomes of 501,942. 501,942. One of those is our winning number. And again, you can create that as a decimal if you need it for some reason. I'm going to leave this answer as a fraction. So in these problems, we need to determine if we need permutations for our probabilities, if we need combinations for our probabilities, or possibly some mixture of the two. You'd have to be very, very cautious as you work through these. Example, probability using permutations or combinations number 3. The Powerball lottery is constructed as follows. Select 5 numbers from 1 to 69 in the upper play area and select one Powerball number from 1 to 26 in the lower play area of the playboard. In order to win the jackpot, a player must correctly select the 5 numbers and the Powerball. Determine how many different Powerball tickets can be purchased. This question is unique in that we don't actually need to find the probability of winning, just how many different tickets could be purchased. We can find the probability easily, but let's just see about how many different Powerball tickets can be purchased. There are 2 stages to this. I'm going to go ahead and actually write 2 blanks, one for each stage. The first is the upper play area, and the second is the lower play area. Now in the upper play area, we select 5 numbers from a total of 69. What's important though is whether the order matters or not. And the way this is phrased, you must correctly select the 5 numbers. It doesn't say in what order, so I'm going to use 69C5 for my upper play area. And then for the lower play area, you're only choosing 1. So actually we don't need a permutation or a combination at all. For the lower area, there are only 26 options. And we'll use our fundamental rule of counting to multiply 69C5 times 26. So I'm going to go over to my calculator. Going to find stat NCR 69, 5. And that number is 11,238,513 times 26. So now I'll just go back over here and add times 26 at the end of that. Oh, wrong place. After my parentheses, times 26. And there are a lot of values here. Let's see. 292 million. 201,000. 338. And if you're interested in what the probability of winning said game is, we know there's only one winning possibility here. And so we'd say 1 out of that value. So the probability would be 1 divided by 292,201,338. And without actually finding that value, I'll go ahead and do that actually. So 1 out of that is 3.4 times 10 to the negative 9. That means 0.000000034. That probability is so close to 0, it may as well be 0. And if you remember, a probability value of 0 is impossible, and the larger a value is, the more likely it is. So in this case, this is a very, very unlikely event. In fact, typically, lotteries are set up in such a way. Now, if you actually take a lottery ticket and look at the back of it, they'll tell you your odds of winning. They don't hide the fact that it's very unlikely that you're going to win, but they also don't advertise it either. So, though you might feel lucky, whatever luck is, the chances of winning are very, very slim. So, proceed with caution. But the reason we've chosen several lottery questions is for that reason. We want to educate you and help you understand that there's a lot of probability involved here, and the odds are not on your side.